Okay, I'm going to go ahead and skip the top of this page here. So just go ahead and get rid of that. We're going to check on objective number 3 here, the monotonicity method. This next method is used when there are more than one election. For example, before an election is held, the voters may discuss each candidate's strengths and weaknesses. At that point, an unofficial election is held to see how the voters stand. This is called a straw vote. The official election is then held after the straw vote. So this is just an example where we would use more than one election. It's my understanding, and correct me if I'm wrong, that the Pope is determined this way. But the criterion for fairness, the monotonicity criterion for fairness, is a candidate who wins the first election and then gains additional support without losing any of the original support should also win a second election. All right, so I gave you guys an example here that shows a really strange occurrence. We're going to work it through together. You're going to need some paper for this one because there's lots of steps. But anyways, it says the members of a television blog team are choosing a television show host to feature on its website. The choices under consideration are Jimmy Fallon, who's represented as an F, Jimmy Kimmel, who's represented as a K, and Seth Meyers, which is represented as an M. To obtain an initial measure of the intentions of the committee, a straw vote is taken. The result of the first election, the straw vote, are given in Table 14.18. So if we look at Table 14.18, this is the straw vote, and this is the results. The real election is the second election, which is shown in Table 14.19, is what actually happens. So our questions here are, using the polarity with elimination method, which host wins the first election? Part B, using the polarity with elimination method, which host wins the second election? And part C, does this result violate the monotonicity criterion? So for part A, remember, if we're doing polarity with elimination, then we have to have the majority for the person to be declared the winner. So I'm looking at Table 14.18, which I have an arrow still drawn there. And we're going to look at that together and figure out how many votes each person gets. So M gets 13 votes because I got that by taking 8 plus 5. Fallon gets 9 votes, and Kimmel gets 11 votes. So the winner, just by doing that, would be M, which is Myers. However, when I take 13 divided by the total amount of votes, which is 33, I find out I have 0.393, which turning that to percentage is 39.3% of the vote. That is not the polarity with elimination method. Remember, we have to have the majority. So what I have to do is take out the one with the least amount. So I'm going to take out Fallon. And by taking him out, all of the votes that went to Fallon now go to Kimmel. Okay, so when we take out Fallon, we have M equals 13. And now Kimmel equals 20. Okay, so which one is the winner? It is Kimmel. So Kimmel is the winner for the straw vote using the polarity with the elimination method. So let's look at part B. And by the way, 20 divided by 33 is 0.606. So I'm okay because I'm up over that 50% majority criterion. So let's look at part B. Using the polarity method with elimination, which host wins the second election? All right, so Myers has 8, Fallon has 9, and Kimmel has 16. So judging by that, Kimmel has a majority, but do they have the majority? So once again, 16 divided by the total amount of votes, which is 33, gives me 0.484. He does not have the majority, so we have to go and get rid of the person with the least amount of votes, which again is Fallon. So take out F. So if I take out Fallon, Kimmel now gets the votes. So what do we have here? We have M equals 8. K now has 9 plus 16. And actually, guys, I'm going to start this one over because I'm wrong. So let me kick back here. M has the least amount of votes. Sorry about that. Do you guys see that? We have to kick out M. So hopefully you're screaming that at me. So I have to take out Myers. So let me redo this. So instead of Fallon being taken out, Myers gets taken out, and the votes now go to Fallon. So Fallon has 8 plus 9, which is 17, and Kimmel has 16 votes. So the weird thing is Fallon's actually the winner here. And the reason why is because 17 divided by 33 is going to be greater than 50%. So he wins fair and square. So it's really strange because in the first round, Kimmel won. Now in the second round, or the real election, Fallon wins. So does this result violate the monotonocracy criterion? And the answer is yes, it does. Because remember, it says that a candidate who wins the first election and then gains additional support without losing any of the original support should also win the second election. But that didn't happen in this case. So it's kind of weird. But that's the answer. So the last page goes over Objective 4, which is a irrelevant alternatives criterion. And there's a small little mistake there. That should say irrelevant IRR. ELEVANT. It says if a candidate is the winner of an election and in a second election one or more of the other candidates are removed, the previous winner should still be the winner. Okay, that makes sense. Let's see what happens. So it says the members of the Richmond Hiking Club are holding an election to select a club president. The choices are Anderson A, Bakari B, Mendelson M, Sanchez S, and Tompkins T. The election results are shown in table 14.20. So this time around, we have 1, 2, 3, 4, 5 candidates. And we're going to be asked to use the pairwise comparison. So for part A, it says using the pairwise comparison method, which candidate wins the election if Mendelson is included. Part B, use the pairwise comparison method, which candidate wins the election if Mendelson is eliminated from the preference table. And part C, does this result violate the irrelevant alternatives criterion? Okay, so remember, when we do pairwise, we're just looking at first place votes. And what might be really handy is to figure out how many candidates we have and how many pairwise or verses we have. So if we look at this, we have 5 people. And then 5 times 5 minus 1, which is 4, divided by 2. 20 divided by 2 is 10. So I'm going to have 10 different pairwise comparisons with Mendelson in the game. All right, I'm going to use the next page here to go ahead and write some stuff down. I'm going to do part A, and then we'll look at part B together and figure that one out. Okay, so part A, who wins the election? All right. So the different people we have is I have B versus T, B versus A, B versus S, B versus M. I just wanted to put a little bit of drama in there. T versus A, T versus S, T versus M, and S versus M. Now I have 8, so I need 2 more. A versus S, and finally A versus M. And by the way, I have these written down. It took me a couple minutes to figure out all 10 of them. So if you're having, an issue trying to figure out all of them, That's why that little formula comes in handy, because then you can see, oh yeah, I'm missing 2. So it took me a little while. I'm not going to lie. All right. So the candidates. B had 40 votes. T had 16. A had 16. S had 8. And M had 8. So just to let you know, I just wrote those on the side. So what I'm going to do is I'm going to circle the winner of each round, and then we're going to count up who has the most. So if I look at B versus T, B had 40 and T has 16. B wins. B versus A, B has 40 and A has 16, so B wins. B versus S, B has 40, S has 8, B wins. B versus M, B has 40, M has 8, B wins. T versus A, they have the same amount, so I'm just going to write tie, and I'm not going to give anybody a point. T versus S, T is 16, S is 8, T wins. T versus M, T has 16, M has 8, T wins. S versus M, tie, because they both have 8. A versus S, A has 16, S has 8, so A wins. A versus M, A has 16, M has 8, A wins. So, first round, B gets 1, 2, 3, 4 points. T gets 2 points. A also gets 2 points. So the winner is Bakari. Okay, so that's the winner for part A when Mendelssohn is there. So let's go ahead and look at part B, which tells us, using the pairwise comparison method, which candidate wins the election if Mendelssohn is eliminated from the preference table. Okay, well, if Mendelssohn is eliminated, and I'm just going to put this on the side here, sorry guys, then we have B equals 40. By the way, I'm still on the last problem. T equals 16. A equals 16. S equals 8. And M equals 8. Remember, I'm removing M, so let me get rid of them. Okay, so now how many pairwise do I have? I have 4 times 3 over 2. I'm going to have 6 different pairwise comparisons. Okay, so the different ones we have is B versus S, B versus T, B versus A, T versus A, T versus S, and S versus A. All right, so if I look through here, B has 40, S has 8, B wins. B has 40, T has 16, B wins. B has 40, A has 16, B wins. T has 16, A has 16, there's a tie. T has 16, S has 8, T wins. And S has 8, and A has 16, A wins. All right, so B gets 3 points. T gets 1 point. And A gets 1 point. So Bakari wins again if Mendelssohn is eliminated. So part C asks if it violates the irrelevant alternatives criterion. And the answer to that for part C is no, it does not. Because remember, it says, if Bakari wins and we eliminate, one of the members of the competition, they should still win. And they did. So that's why it does not violate the irrelevant alternatives criterion. Finally, there's 2 pages, or actually 1 page. It says 2 tables. Table 14.23 is just showing you the 4 fairness criteria. And table 14.24 shows you which ones always satisfy it. If you notice that border count method may or may not satisfy, so that one's not really a great one to use if you're trying to be fair. But to be completely honest with you, they all will break down at some point, and none of them are truly 100% fair, which brings us to Arrow's Impossibility theorem. It is mathematically impossible for all democratic voting methods to simultaneously satisfy each of the following fairness criteria: the majority criterion, the head-to-head criterion, the monocracy criterion, and the irrelevant alternatives criterion. So it's up to you, if you're running a business or you're running some kind of voting method, what you're willing to live with in terms of something not being fair. And that's the end of 14.2.